Now we are in number exercises 7 through 12. Let's see what is in exercise 7 through 12. All right, let's read this all together. Find the linearization at a suitably chosen integer near. Okay, I put that in a box. That way you'll know what we're really looking at. Near x of 0. Okay, at which the given function and its derivative are easy to evaluate. All right, so basically what's going on? Our x of 0 is 0.1. Now, a linearized version, and if I just plug that in here, okay, without the calculator, it's more complicated, but if we have a linearized version, then it's easier to evaluate. But we got to evaluate it locally. What is the closest integer to 0.1? It will be, that's what they're asking here. That's all it is. So it's like finding the a. That's what you're doing. A here would be 0. Here in number 8, a is, okay, what's the closest integer? 1. What about here? What's the closest integer? -1. What's the closest integer? 8. Same thing here. What's the closest integer that we can get? 8. I mean, look, actually you have a choice here between 9 and 8, right? But it's the cube root, so which one do you choose? Of course you choose the perfect cube. So a is 8. Okay, and then here a is 1. Find a linearization at a suitably chosen integer near x of 0 at which the given function and its derivative are easy to evaluate. And again, what have we chosen? Our a is equal to -0.1. I'm just looking at 0.1 at, number 9. And the closest integer to -0.9 is a is -1. And we will see why this is the picture that I have here, okay, in a little bit. But before we do that, let's go ahead and find our linearized version. F of x is equal to 2x squared plus 4x minus 3. What's the first thing we do? F of -1. F of -1 is 2 minus 4, that's -2, minus 3, -5. And that's really where it is. There's your -5. Okay, and then take the first derivative. That's 4x plus 4. And then what is f prime of -1? Well, what do you think? We already see here, this is the zoomed out version. Or rather, the zoomed in version. So look, that's 4 times -1 plus 4, you get 0. What have we found? We found that the linearized version of this quadratic is a horizontal line. And what is now the equation? Well, we don't need to use our linearized version because the slope is 0. You're just saying that L of x is equal to what? -5. It's -5 plus 0 times. You see what I mean? But it'll just be 0. So we've got a horizontal line. It just so happened. So zoom in here, and this is where we have. So when x is equal to -1, so what are we doing now? What is this? That means if we were to approximate L of to approximate f of -0.9, then what is it? It's equal to this one. L of -0.9 is -5. This is now the approximation. So to approximate that, it's equal to negative 5. Now what is the actual? What is f of negative 0.9? That's the question right here. Well, let's find out. We got negative 4.98. So what is the difference between the two? Okay, so negative 4.98 minus negative 5 is what? It's just 0.02. Okay, so that is the difference between the two, and that's not bad. That's very close to 0. So it's, but look, suppose I want to approximate f of negative 0.5. Oh, if it's negative 0.5, look, this is the approximation using the linearized version. Okay, that's the error, that's the difference. This is our f of negative 0.5, and this is our linearized version. We can't use that. We can't use this approximation because there's a big gap between the red curve, the red line, and the actual curve of the quadratic. So sometimes there are areas on the curve where if you just wander off a little bit from A, negative 1, then you already have a big gap. So sometimes it depends where your tangent line occurs. What did we say our A here? Our A is 8. And so let's go ahead and find the linearized version of the cube root of x. F of x, I will write this as x to a third. That way we know how to take its derivative. And then what is our A? Our A is 8 because we need to find a perfect cube. So we can't choose 9. So what is f of 8? It's 2. So now take the first derivative of x, and it's 1/3 x to the negative 2/3. Okay? And so what is that? That is equal to 1/3 times the cube root of x, and then you square it. Okay? Because that's what this means. So now what is f prime of 8? That's just 1/3 times, what's this, the cube root of 8? It's 2, square it, so it's 4. 3 times 4 is 1/12. And look, here's x equal to 8. And this is what I'm saying. Like if we approximate the cube root of 8.5, that's a 0.5 distance from 8, and we still have a good approximation. Okay, but we're not done yet. We're not done yet. Let's go ahead and write our L of x. L of x is the y1, which is 2, plus 1/12 times x minus, what is our A? 8. What do we say now? We're saying that the cube root of x is now approximated by a linearized version, which is 2 plus 1/12 times x minus 8, near where? Near the point 8, 2. And as I was saying a while ago, if let's say this is 8 and this is 8.5, this is zoomed in, and that's 2, and there is the cube root of 8.5. Alright, you see how they practically coincide with each other. That's just, if we zoom in here, that's what happened. This is what we're looking at. We zoom in this and we get this picture. We will stop right now, but no. What about if we use our calculator to find out the cube root of 8.5? Right. This is, since again we are looking at where we're going to compare the cube root of 8.5 is equal to 2.040827551. That's what my calculator says. Now, what is the linearized version? So L of 8.5 is equal to, it's 2 plus 1 over 12, if you go back, you know, from the previous slide. And remember, our x is now 8.5 minus 8. So what we have is 2 plus 0.5 over 12. So what is that? This is equal to 2.0416667. And so we take the difference, okay, the square root of 8.5 minus its linearized version is 8.39115. Let's just say 567 times 10 to the negative 4. Okay, which is really saying it's 0.008391157. That is a very good approximation, a very good difference. This is what I'm saying, that it depends where sometimes your linearized version occurs. Why? Look at our graph. You see, even if you have a big gap between 8 and 8.5, that's a 0.5 unit difference. The lines are practically, the curve, the yellow curve and the line are practically, basically coinciding with each other. But go back to the quadratic function. Here in the quadratic function, if we try to approximate negative 0.5, which is just a 0.5, it's also a 0.5 unit from negative 1. And did you see? Wow, that is a huge gap. So we can't use the same approximation here as we did in the cube root of x. And the next thing we'll do is we will look at differentials.